doing something. So welcome to our middle school science teacher professional development offered by Purdue University College of Science K-12 Outreach. Today we have Jessica Brewer, our K-12 Outreach Coordinator from the Department of Computer Science, and she is going to do a little bit of Python and other stuff, or just Python?
Basically Python.
Basically Python.
Yeah.
Okay, so I'm going to turn it over to Jessica, and it's all you.
Okay. All right, everyone, welcome. It is great to see everybody answer in the chat. So I love the fact that we have very little coding here, because that makes my job more fun, because then I get to help out you guys hopefully have a better understanding for some basics for computer science and coding. So for my last session, you guys can all see my screen, I'm assuming. So for my last session, I'm up here landing on the moon with block code. So if you weren't here or able to attend that one, you can go back and see more on just block coding. Today is based in Python. It's just a different language. The unit plan is there, and then also the recording from that one. If you go down to today's, you can go into unit plan. I also posted that in the chat, the link for today's session and that. Let's see if I can get my toolbox to go. There we go. So this is what you should see for today, the unit plan, exploring our universe with Python and algorithms. As we get started, I want to take a few minutes. I guess should I introduce myself?
Sure, go ahead and introduce yourself.
All right, so I'm Jessica Brewer. I just left the classroom in January. Purdue poached me. Happily, no.
Yes, happily. Well, happily on your end or happily on our end?
I think everybody
Okay,
said.
all right, good.
I was teaching, I was into my 7th year, 6.5. So I was teaching I don't know, somewhere in there, 6 or 7 years. And my last 3 years were focused in actual computer science for both middle school and high school in a very rural school district in Wabash County, Indiana. Yeah, I've done a lot of other different fun things before I became a teacher. I was in Canada and Argentina doing uranium exploration and got started in GIS and remote sensing through that, and now here I am. So, so back to, I guess, the unit plan. So hopefully everybody's able to open it easily. Just real quick, I'm going to run down through, and there are six different lessons in this, and then I set up a final rubric in the final game code that you can find all the way down here at the bottom. And we'll go ahead and get started in CodeHS. So if you guys can follow along, it makes it even better, but if you just want to watch too, that's totally fine. So I really like CodeHS for the fact that it has a bunch of different tools, and most of them are free. There is a paid version. If you're able to do that, I don't not recommend it, but it's not necessary. So I'm going to go into my CodeHS page. It can get a little clunky sometimes, but other than that, I really like CodeHS just with what it offers. It's what I use in my high school classroom, and I think I did one section in my middle school classroom, but anyway. So my high school classroom, I use CodeHS. When you come in here, let's see if I can get rid of that one. Yes. Woohoo. Now I can see my whole screen. Sorry. So as you come into CodeHS, it's just codehs.com. Oh, I'll sign myself out. You'll probably come to a screen very similar to this. For today, you don't feel like you have to sign up or log in. You don't have to do any of that for today's session. I will say if you do end up signing up, and you're in like your teacher page, which is what I have up right now, you are able to set up under my sections, go to your teacher page, which it won't let me because I'm not signed up as a teacher right now, but you can easily import all of your classes into, oh,
Okay. I can do it.
Bill's on it. You can easily import all of your classes into CodeHS. You're able to grade and all, just you can, there's different tutorials you can take. I promise it's really not that difficult as you get into there. So today we're going to be working in CodeHS. If you are on this page here right now, if you just click on the online IDE, and then you're going down to Python, and then we're going to be working in Pygame today. So you can go ahead and click Create New in Pygame and get started. So I'll give everybody a few minutes to get to this page, and then just in the chat, if you have issues with it, let us know.
So I added three links, really two links, and then I typed the last one in. But the first link is to the main page that has all the professional developments that we've done this summer and the two that we still have to go. And then the second link is the link that Jessica is off of Jessica's presentation for today. So that's that second link. And then the last one, I just typed in codehs.com in case you needed to get to there.
And if you need it, it's at the bottom of the, I linked it at the bottom of the page for today as well.
You are welcome, Sue.
So the other great thing about CodeHS that I really appreciate is you can download PyCharm. You can use the Python idle in your command line on your computers. You can do that, but really the way CodeHS has it set up is so simple because it already has a lot of the libraries loaded into it that you don't have to mess with. So if you're beginning coding, I really suggest CodeHS. There's different ones you can try to Replit. There's a new one on Google that they have out. But as far as what I guess I'm most comfortable with, I've used CodeHS. I know it. I understand it. So that's why I chose it for today. And it's just so much simpler than downloading PyCharm. And
it is also, apparently it's withstood the test of time because right when COVID hit, we actually hired a high school teacher to do some stuff, and she did everything in CodeHS.
Oh.
And she was like, "Oh, here's how you do this."
Yeah.
So clearly that was a couple years back. So
yeah. Yeah, and if you're a teacher in Indiana right now, they have all of their professional development available to you guys for free as well. So you can take like CodeHS's online professional developments if you're from Indiana for free. I don't know about other states. I just know Indiana.
Right.
Okay. So you should be in Pygame up here. If you could in the chat real quick, say if you are or you are not in there.
Thanks, Chris. Amy is, Sue is not.
Okay. All right, Sue, I will start back where I was before. So as you're in CodeHS, you don't need to worry about logging in or signing up today. You're just going to go to the online IDE. Into Python here. We're going to scroll down and use the Pygame for today. Oh, I did use CodeHS with my middle schoolers, and I used the Python turtle. If you have time to play around in Python turtle with some of your middle schoolers, it is pretty fun. Like these kids get into some of these competitions and with each other on how quick they can complete lessons, and it's hilarious. But anyway, so you're going to go into Pygame, Python, and create new. Default is fine, and go ahead and hit get started.
Did that help, Sue? Did you get in? Don't want to leave anybody behind on this part. This is kind of the.
Does your dashboard, are you, I don't even know if it'll let me log back in now. Is this the dashboard? Aha. So you're going to go up to sandbox. That brings up another great point. If you are logged in, you'll just go to sandbox. And you can type in any name here and hit.
Hold on. So she did PD _ Python.
You can, yeah, that's just the name of how it'll save it when you come back.
Oh,
Yeah, so you'll hit create program. And then, see, that's the other great thing. Thank you, Sue, for this, because the other great thing about CodeHS is it allows you to code in all of these other languages as well, and it's all in one spot. So we're on the Python column, and I'm going to come down to Pygame, and I just selected it and hit create program.
and that was because she was logged in as a teacher.
Yep.
Okay.
Or logged in as herself. Yeah. Perfect. Yep. Perfect.
Woohoo! We like little mini wins. Right there, that's a mini win.
And then it helped me help you guys for later too if you're teaching. So that brings up the next great point. The sandbox is and can be your best friend because it allows you to go in and test things, and it allows your students to go in and play around as well. So yeah, great, sandbox. So I'm going to go back into PD Python. It looks the exact same, I promise, as where we went before for the others. I have a lot of windows open up. Python. I close the one I'm on. Nope, here we go. Okay, awesome. Okay, so if we go back into our unit plan, you can either right click or do a 2-finger click or just click on it and you're going to open it. I like to open myself in a new tab. And here is lesson 1 on Introduction to Python Basics and Algorithmic Thinking. So this is like the bread and meat of your of the lesson or of the unit plan itself. So I have it broken out into 6 different lessons, as I was saying, and they each build on each other. So we're starting with like the very basics of computer science in Python, all the way up to, by the end, you should be able to create a game, and your students should be able to create a game. I don't know if I'll have enough time to get to the game, but at least like I will give you guys like really great basics for Python and where to get started, and then you guys can finish it out from there. So for lesson 1, this is literally the basics, like how to create variables, how to create what a data type is, and understanding what basic algorithms are. So the best way that I can explain computer science to you and how I feel like the best way to get students to understand computer science is it's all based on algorithmic thinking and this algorithms and what an algorithm is. So basically your algorithm is you take a big problem and you're breaking it into small steps and how to solve that problem. If we go down to, oh, I guess I talked about stuff before, like what is an algorithm. So if you start at what is an algorithm, you can think of it as you can explain it to kids. Brushing your teeth, baking cookies, making a sandwich, anything that you have a routine in day by day, and you follow specific steps to do it, that's an algorithm. So basically in computer science, algorithms, we take these complex problems, we break them into manageable, smaller steps, and we find our solution. That's computer science. If you can teach your kids anything else about computer science, that would be it. I have an example of a different algorithm that you can solve through coding. It's a very simple one. That's all right there in the lesson plan. But what I want you guys to, for today, to get the feel for, is what a variable is and data types out of this lesson plan. So I'm going to have another plug here. This book right here, Everything You Need to Ace Computer Science.
Unshare your screen so they can see it.
Oh,
big.
okay.
It'll be easier to see it big. There you go.
And,
Yep. If you start talking, you don't need to turn on your camera.
oh, okay.
Okay.
Oh, I see.
Yep.
Oh,
There we go.
so this book right here is probably one of the best books that you can have as a resource. It breaks down computer science super simple. Even at the end of each chapter, it has a review. It gives you the answers to the review, so you can scan the pages for your kids, have them read it, give them a quick, easy test through whichever learning management system you have. That's how I did it. But it starts it all the way back to the very simple. It gives a brief history. It talks about paired programming and how it's, how you can best work with a partner while you're programming, working on teams. I put a plug-in for it on my last one too. It talks about all the different block codes in Scratch. So if you've used Scratch before, this also has an entire unit on Scratch and block coding. And my personal favorite is Unit 7 is all on Python and Python coding. And it breaks it down. So basically what I'm talking about today, it breaks it down into similar chunks to mine, maybe a little easier to understand depending on your learning style. But I just really appreciate this book because of what it offers. Okay. So back to, so if you have that book and you want to get it out right now, go for it and turn to Unit 7. It's the orange unit. As I always told my students, we're going to the different colored units. Okay, so back to share. So we understand what an algorithm is. It's big problems, breaking them down into smaller steps so that we were able to efficiently solve our problems. And then, oh, this right here, it's just to get your kids on board. It says use an example Python code to pique interest. And literally, if you put it in there, it'll draw a smiley face. I don't need to bring that up right now. This is the important part. So comments, variables, and data types. So for commenting, basically for commenting, what you need to understand, and I always pushed it like right here, it's crucial to emphasize the importance of commenting early in the learning process, because the more that they are able to comment what the lines are in their code and understand it, they have a better understanding and are able to communicate with others what they are seeing as they're coding. So this one here, it's way over commented, but also it explains line by line, right? Sets the turtle's drawing speed, sets thickness, moves. It tells you line by line what's happening. You don't need to do that excessively, but I do highly recommend that you push commenting. Yes.
So you're telling me that when they're typing in the code, if they put, is that a star?
Hashtag.
Hashtag, I couldn't quite see it.
Yeah.
So it's a hashtag that they can type that in and that does not code anything?
Correct.
So that just gives them knowledge as to what that is doing.
Yep.
And so as a teacher, then you see, I didn't know that.
Yeah.
Okay.
So one of the other fun things that I used to do is I used to give kids code that had no comments on it and give it to them and say that was like their test. Like they had to figure out what the code was doing and comment out like certain sections. Like saying this is what happens in this section and explain it out. It's another
Assessment.
assessment, yes. Okay, so that's commenting. Use the hashtag. We'll get to there. So you should be able to highlight the example code. I really hope you can. I have it set up that way. So if you're in lesson 1, I'm simply down on the variables. I give you different talking points on variables, data types, etc. I'm just simply copying this first example code on page 4. So then if you're in your sandbox, you can do, I'm trying to think what it is in not a map.
You want me to see?
Because it's Command A for a Mac to select all. What is it in on a PC?
I don't know.
Is it Control A? Oh, Control A. There we go. Just click in there.
Where am I?
Anywhere. You can click anywhere and hit Control A. And it should select everything. And just hit delete. And you have a fresh page. And so then you're going to copy in. Oh, see, it commented everything out. Ugh, okay.
Mine pasted right in.
It did? Okay. Try this again. VNC. VNB. Okay, let me.
So all we're doing is deleting what was in there and then cutting and pasting that in.
Yeah. Well,
I think I know why it's doing that to you though.
why?
Go back to the other one. So, select all that first. Now copy. Now go back over. Huh. Oh, try a paste.
Oh my goodness. Okay, well, I will bring up the Word doc real quick. If you have issues with it, let me know. I'll put it in the chat.
Want me to put it in the chat?
Yeah, if you want to.
There, you can cut it and paste it from the chat if you have to.
There it is. Okay. Shoo. There we go. So basically, line by line, what we're seeing here is line 1, what I have highlighted right now on my screen. Oh, well, I'm glad it worked for you, Sue.
It did?
Yes, that's awesome. So line 1 is the comment, right? It's a dark green. It has the hashtag, so it will not be read. The program will automatically skip over that. Line 2 is our variable. So this is in Python, the variables are information holders. You can create multiple variables, you can create one variable, but a variable is simply an information holder.
Okay.
And you name it. And the data type of this certain variable right here is a string, because it has quotes around it.
It's a string?
It's a string.
What's that mean?
It means it's just a combination of letters or numbers, but it's in quotations.
Okay.
It's just, I'll get to that in a second.
Okay.
So line 3, another comment telling us that our variable is a distance from the sun. And this data type is a float, which is different than an integer, because an integer would not have a decimal place. But since it has a decimal place, it's a float. And then a print statement. So if you have this in here and you hit run, you should have a sentence down below that says the sentence, or the distance from the sun to Mars is 227.9 million kilometers. Oh, take out your line 6, Bill.
Take out line 6?
Yeah, and then it'll work. I don't know why that. Oh, or you could have hashtagged it out. I see what happened.
Okay.
So see, now you, was everybody able to get the sentence to pop up? Syntax error, is it line, here, wait, I think I know what happened. So for some of you, it might have shown up like this, like line 6 was in a different line. You can either delete that out completely, because see, if you hit run, it should say that you have a syntax error. And if you look at it, it says line 6 right here. So you know you can come back to line 6 and fix it by putting in a comment or deleting it out and hitting run, and then you should have a sentence pop up.
That worked.
Perfect.
I had the same problem, Sue.
Yeah.
So,
Some
okay.
copy and paste can be wonky too. So if that does happen and we're not on together, don't get overly frustrated. Just kind of go back and look and see what I have written here. Because see, I think what happened was is it counted this as in a line and it didn't need to.
Yeah, it did. Yep.
Okay. So then I go through, so that's integers as whole numbers without a decimal place. Floats have a decimal place, and strings right here, they're a sequence of characters, words, phrases, or numbers, but they're in quotes. Those are your 3 different data types that you'll work with in Python. So then I just give a quick overview of algorithms and breaking down how to calculate the time light takes to travel from the sun to a planet. And of course, I gave example code. You're more than welcome to copy and paste that in. And then you can come back in and have your kids even comment it out further to say, this is the steps they took to solve this problem. And I'm going to see if this copy is from here. Nope. I wonder why he's doing that. That's so weird.
What are we doing now? Sorry, I was looking back at
Oh
the,
no, you're fine. I was just playing around. Sorry. So basically, if you go through this, you're understanding your problem. So we need to know how long it takes us, or how long it takes light to travel from the sun to a specific planet. And what do we know? Well, we know the equation speed is equal to distance over time. We know the distance between the sun and the planet, and we know the speed of light. But what we don't know is time. So we rearrange our equation, and then we start to implement this in code. So we're able to use variables to store the distance and speed of light, which I will go ahead and pull that in. So I wonder, I guess I could split screen. It's fine. Okay, so we have our variable set up for the speed of light. We have the distance from the sun in kilometers. And then we have another variable set up with an equation, with the equation behind it, which is the distance divided by the speed, and then a print statement. So light takes a certain amount of time, and I explained this to you in the lesson, like you're able to print sentences by putting your print statement and then quotes around what you want to show up as words and bringing in your variables followed by a comma. I promise when you go back through this, it'll be less confusing. It's just we're short on time already, and line 4. What did I do on line 4? Oh, did I forget to bring in a line? Oh. I forgot a line. I need to write that. Can you write that down so I can fix it?
yeah.
It's equal to say Mars. So you're able to come in and say light takes this big long float, see all the different numbers after a decimal place, seconds to travel from the sun to Mars. Oh, see, I fixed it on the hands-on activity.
Of course.
Of course I did. So there's some vocabulary here that you can work through with your students as well. Step 3 is a hands-on activity, and this is basically the worksheet below. So if you come down to the worksheet, it is blank here. You can have the kids write stuff in here or do it on their sandbox and show you. However you would like to do that in your classroom, whatever is easiest for you, you can do that. 3 different sections, and then I give you an answer key for it. And then at the end of the day, or at the end of the lesson, I also give exit tickets. So basically how I have every single lesson broken down is you have an intro that involves some sort of engagement, getting them excited about the day. An explanation where you take a few minutes and explain what is happening and going on for the day to them. A hands-on activity, which is generally the worksheet where the kids are working through the code themselves. And then a review where you ask any questions and give answers, and then give them an exit ticket as they leave. So that's how every single lesson is set up. Are there any major questions or issues with Python maybe that you have before we move on to different a different lesson? Anything over algorithms or basic, Python ideas around variables? Or if you're completely lost and you're like, I have no idea what's going on.
I'll speak while you guys are typing if you're typing. And I taught middle school for 12 years, and so I'm thinking about how I would clearly every time I see a lesson plan or what people do, immediately I'm thinking how I would modify it for what I'm going to do.
Right.
Which is what teachers do, right? I mean, they take something and then they go, but what I love is that you have a lot of stuff in here that you can cut and paste in. Maybe I might pull it out, maybe I wouldn't, maybe just depending on how I want to do it. But I think one thing I would have done as soon as you did like the first part with the distance to the sun, I think I would have said to the kids, okay, change this enough to make it do X.
Yeah.
That way they were kind of playing with it so they get it. What happens if you take this line out? Oh, nothing happens.
Yeah.
See, nothing happens. So that whole asterisk and then going, they understand.
Yeah, that brings up a great point. That I did leave out a big section of like debugging and understanding syntax and stuff like that. Another PD, I guess.
Yeah, right. Sure.
Just on debugging. So there's lesson plan 1. I will open up lesson 2. And this is basically on inputs and outputs and conditionals. So from here, you're going to learn how to use the input and output functions in Python and understand and apply conditional statements. The engagement, I gave you some ideas for how space science uses data to make informed decisions, specifically with the Mars rover and the insane amount of data that takes in and how they use Python to decipher it all. So it's pretty cool, actually. Like you can go down a whole Google rabbit hole of how NASA uses Python and like all their daily stuff.
Okay, I'm going to stop her for a second. They're doing some banging up above us. Can you guys hear that? Because if you can hear it, I'm going to go ask them to stop. Okay. Thanks, Chris. All right.
Okay, good.
We'll keep going then.
It's just bothering us.
It's bothering me probably more than anybody, but all right.
Okay, so that is some intense, like that's like Irish, what is the
Logging.
Yes, yeah. So so as we're going through this, as you're going through this, you can give this example code, you can change it to however you want to. The best part about what I enjoy about this is, yes, yep, CodeHS is web-based, and so you can use it on whatever, you can use it. My kids used it on iPads, we had desktops, we had Chromebooks. We didn't have Chromebooks. I've had Macs, but yes, Chromebook is totally fine. So the example code here, I tried to comment stuff out as much as I possibly could. So basically what this program is doing is it's taking user input, asking that user for the name of a planet and its distance from the sun, and then it gives all of that information back to the user. So just like we used variables before, right here, planet name again is the variable where the information is stored. And when you get ready to use an input statement, you literally just put input in front of it and then quotes around whatever question you want to ask them or prompt that you want to give them. And then another prompt of, another variable that has to be defined to take in more information. And then it's displaying the information in a readable format. So basically it's taking in this stuff from the user and displaying it out into a complete sentence. So it probably won't work again, but we will certainly try. And I'll have to bring up the I wonder if I can just don't mind me. But as you can see me working through this, you can see my text change colors. And the book in here, it literally goes through all of your different helpful colors if you need to go back through. So you can see like it's black right now, so I know that it is what the program is going to use. If it's green with the hashtag, I know that the program will skip over that. So if I hit run right now, what should happen is we should get a prompt asking for the name of a planet first. And we do. Enter the name of a planet. And you can put in any name you want to. Hopefully, the kids put in names of planets, but you can put in error checks later. That's a big, long, I'm just trying to keep it simple. So enter the name of the planet. We're going to say Mars. And then it gives you another prompt. So after you hit type in your answer. Yes, I did copy all of the example. You're going to enter in the distance of the planet from the sun. And so I typed in my number and I'm going to hit enter.
And where did you get that number?
I just put it in from my head.
Oh, from your head.
Yeah.
Okay.
It's not the actual number.
Okay.
You actually have to like look it up and stuff, and I don't know that.
Okay. Fair enough. I just didn't know we got the number.
So then you'll have so then your last answer is the distance from the sun to Mars is 445 million kilometers. So if we break this down, right, we have our planet name where it asks us to enter the name of a planet, our variable distance from the sun in kilometers, and that's where it asks us to enter the distance. And then we printed it, the distance from the sun, and then we put in that variable name. And we say the planet, so we put in that variable name is, and it's in quotes again, and then we use that variable name again to create our complete sentence. What is your syntax error?
EOL.
Can you make that box bigger by?
I'm going to move this box.
Yeah. Line 6. Distance from the sun. What distance did you try and put in?
I haven't done anything yet.
Oh. Scanning string.
So let me run it again. Okay. There's my,
The end of line. Oh, take out that last quote and
right here.
wait, no, that should be in there.
Right here. That.
Yeah, take out that one. No. Oh, it didn't copy it correctly. Did it?
I'll do it again. Good. Go in with them.
Okay. Sorry. Huh. Well, because I think someone else said they had.
I wonder if you do it.
I wonder if I need to put it in, if I need to put my Word docs up. Yeah, see, that's weird. Well, this is. So line 2. I will put my Word docs up after this. So I guess if you just want to follow through the different lessons to see how I have it all fit together, we'll do that, and I'll pivot and not do anything in CodeHS right now. Does that make sense?
I would still do it in CodeHS, but you do it. And then,
Okay.
like you said, then I think it's the cut and the paste is causing our
Yeah,
problem.
yeah. Okay. I will find out. Sorry, everybody's having issues. I will find out a better way to copy and paste this, and I'll work with Bill after this, and we'll get up new documents for you guys. So anyway, we've gone through the introduction. We've introduced this idea where Python can take in information and give information back out based on what we tell it to do. And then we head into our explanation of the input and output functions. So this is input is where, we have the input command with the parentheses, and then whatever we have in these parentheses is what it will give to the user. So right here we have our variable, and then literally we have input with our parentheses, and anything that we have inside of here, that's what the user is going to see. So if we go back over to Python, you can see it says enter the name of a planet, which is exactly what we have here on line 3. So then we're able to comment everything out here where it says the input function displays a message within the parentheses and waits for the user to type a response. And then once the user presses enter, the response is stored and then it moves on. So you can even ask for multiple inputs like we just did. And you're able to display your collected information in a readable format. So if I bring in this example code, like here on line 1, it's saying it's asking the user to enter the name of a planet. I'll name my planet Jessica. Enter the distance of the planet from the sun, like it tells us here on line 4, and then line 5 asks it to store it in that variable. And I'll say that I'm 1,000,000 miles away. And I hit enter, and it brings in that information. And then how many moons do I have? 9. I have 9 moons. Like it asks on line 8. So see, we have, now it's storing that number and number of moons here. It's asking the user to input, right, the number of moons. And I hit enter after that. And it gives me back my information to me in a sentence. The planet Jessica is 1,000,000 kilometers away from the sun and has 9 moons. So we have our print statement here, and anything in quotes, right, is what are the words. We're able to use the variable names. So we're able to bring in information, store them in variables, and then print that information back out. The next Python basic commands are conditional statements. So conditional statements, they are very fundamental in programming because it's now allowing you to say, if I tell my program this, it does this. Or if it doesn't do this, I can tell it to do this and continuously break it out. I will bring in the longer code here at the end, just as a quick
Thank you, Amy, for letting Sue know that.
Yeah. So here's a great conditional statement that I have up right now. So in line 1, I am asking the user for an input to enter the distance of the planet from the sun in millions of kilometers. And then from there, I'm saying if the distance is less than 150, it will print out the planet is relatively close to the sun. Or if the distance is greater than 450, the planet is far away from the sun. And then if it's between there anywhere, it'll say it's a moderate distance from the sun. So as I run this, I'll put in 7 this first time. And what should come back is the planet is relatively close to the sun, right? Because we're less than 150. And that's exactly what happens. So then if I hit run again and I put in 890, right, we're expecting it to skip this first part, right, because it's not less than 150, but it is more than 450. And so our print statement, the planet is far from the sun, should come up. And it does. And then if I run it one last time and I give it 300, right? It now skips the first if statement, skips the elif statement, and it should print my last statement. It's kind of how that works. Like I said, this is quick and I'm sorry.
No, that's good.
But that's the easiest way I know how to do this. So this right here is probably one of the most important paragraphs out of all of these lessons. The importance of conditional statements in decision making, because as you're going through codes and you're coding and your students are starting to code, if else statements, they will use them 9 times out of 10 in most programs, just because of it simplifies the order of what is actually happening in their code. So this paragraph here is just simply explaining all of that, right? We have better efficiency, we have better flexibility, and you're able to control the flow of your code. So that way you literally don't have 100 lines of code when you only needed like 50 type of thing. So that's the importance of, these else if, elif statements. And again, I have the examples on here to help you guys out, understand what's happening in the worksheet. An exit ticket that you can give at the end of the day for your students. And then the worksheet that walks them through the different tasks for the day, and then an answer key at the end. Any questions over lesson 2? Perfect. So lesson 3 is all on looping. Looping is probably one of my favorite things to teach just because it kind of blows the kids' minds at the beginning, and I think it's awesome to see it when they're like all their little light bulb moments that they have when they start to understand what loops can do for them. It's just a lot of fun. So I'm going to bring it up in the Word. So basically with loops, they're almost as important as if-else statements because they are able to bring in that repetitive factor into the code and for students to be able to shorten their code so they don't have to keep repeating and repeating and repeating the same code over and over. So I'm going to bring in this example code here. So for looping in Python, there's two different types of loops. You have for loops and while loops. And the first loop we're going to talk about is the for loop. And it repeats the action a specific number of times. So like for however many instances, it will do exactly what I tell it to do that many times. So if we look at this code here, so for I, and this can be any variable, in range 5, this loop, it will print this loop every single time, right? Here's your print statement. Which I don't think I have it set up right. Maybe I did. Oh, I did. Okay, good. So this, so you can see here, it starts at 0. That's another thing that kind of throws kids for a loop too. So if I change this to for I in range 4 and hit run, right? We expect it to only run 3 or 4 times, but we expect it to only get to the number 3. So you're literally telling it for this number of times, I want you to print this statement. That's all it does. That's as simple as a loop as you can get.
And the I for I in range, what is the I again?
I just stands for iteration.
Okay.
You can put any letter number in there that you want.
And it still will do it.
Oh, because I have I here and not K.
Oh, I see. So as long as those are, okay.
Yep, as long as those two match.
Okay.
Yep, perfect. And then while loops, this is, it will do it as long as the condition is true. So I'll bring in a while loop here. Oh, it won't, I don't know why I even tried. So we can see it's different because we have to have this count variable up here, and you can have this count start at anything you want to. Just understand that it's going to change your counter down here. So I'll run this first. So let me comment this out for a second because I want you to be able to see the difference. So as I run this, right, it started at iteration 0. Now, if I start this count at 3, right, it will only go 3 and 4 because it's less than 5. If I switch it to equal, oops, you now have 3, 4, 5 because your count every time you go through this plus equals 1 is it's adding 1 to whatever your number is here. And then if this is just less than, well, 4 is less than 5, so it will run, but 5 is not less than 5, so it won't run that loop. Hopefully that kind of makes a little bit of sense. So you can see here for this variable in range whatever, it's going to keep printing, but the while loop then, as long as this is true, it'll keep running. Oh, I should have commented out. Anyway. Any questions on looping? But it is kind of fun to see the kids like, oh, I get it. So how this is applicable to our space science, right? We can say that there are 5 orbits, and this planet has completed orbit number, and then it walks you through like 0, 1, 2, how you can apply it to space science. Same thing, there's a worksheet below with examples for you, an exit ticket to give them before they leave, and your answer key.
That one I like.
Yeah, looping.
Yeah.
Yeah.
That's pretty.
Then lesson 4 is where we start to get into Pygame. Pygame becomes a little bit more difficult, I will say that. And this is where kind of that advanced coding more comes in. But I did walk, and I think also one thing that we need to understand too is that our students sponge so much more up than I think that we give them credit for sometimes. And so as you're going through these and you get frustrated and you give them, you start to think about how you're going to give them to your students, and where kind of they might get frustrated is you can pull in a big mindset game into this. You can also, turn it into a huge learning opportunity for them to like, okay, here's your basics. Here's what I'm giving you. Take it and run with it and have fun type of situation. However you want to take this. So, I guess this could go 2 ways right now. I can keep going into Pygame and into further, or we can go back and we can spend some more time on the basics of those first 3 lessons. I kind of, what are you thinking? Or
I'm not going to speak for all of you, but as you were doing this, I was thinking in my head, okay, here's what I would do. Here's what I would do. I'll go back and I'll play with each one of those first 3 lessons to kind of tease out where I want it to go. So I'm okay with you moving on to the Pygame.
Okay.
What the teachers that are still here, what do you guys think? Keep moving? Agreed. Okay. That's 1.
Okay. Move.
Yep. Okay.
Perfect.
Awesome.
Okay. Awesome. So as far as Pygame goes, it's just a library set up in Python. So Python is set up to have all of these different libraries that have different access to different codes behind the scenes that we don't see, but we can still use. So Pygame is just a different library within Python that enables us to have bring up scoring, bring up different graphics, bring up being able to move and manipulate things that we create. So essentially creating a game and using Python. So I will go ahead and import this code here. And for those of you that are still here and still watching or watch this again, I learned something very important as I was going through this. I was working in PyCharm on some of my stuff, and then as I was hashing this out with ChatGPT, because if you don't use ChatGPT to create lessons, then I'm sorry. Because it's awesome, because I have a back and forth a lot of times with ChatGPT. Okay, I don't like this. How can I, change this? How do I do this? So I was working in PyCharm on this, and I went to bring everything into CodeHS to make things simpler for, the teachers that don't understand PyCharm, and because that's a whole, you have to choose the level of Python you use, you have to choose, you have to import even more stuff. Anyway, so I will say, and I probably should put this as a disclaimer. If you are using CodeHS Sandbox, you have to have these 4 lines of code, or else it will not display correctly in CodeHS. So without these 4 lines of code, you can have the most beautiful code you want, and you bring it into CodeHS, and you're like, crap, I'm getting error messages all over the place. Finally, after lots of Googling and figuring out and looking at other people's games, I was able to figure this out. Lines 2 through 6 have to be in there. So as we look through this code, we're importing Pygame, right? We're importing that library. And from Pygame, we're importing and anything that it could possibly use. That's all that star is. And we're importing the operating system of Python in as well. So I'm not going to get into the nitty gritty of importing and all the libraries that you're going to need to understand because, well, A, we don't have enough time, and B, I really don't understand the background stuff. I just know that I have to import different libraries, whether that's good or bad.
Yeah.
That's what all the professors are for, right? To figure out what those libraries are. I just have to import them to make it look nice. So then we're initializing the game here on line 8. Lines 11 through 16 are basically setting up this window over here where it says graphics are disconnected, right? So if I click here to reconnect, it should just be a black screen that comes up. And then here's our loop for while it is running. So basically it's saying, I will keep running this game as long as nobody hits the down key and nobody hits the escape key. And then here, and I'll show you guys how to play with this as well. They use the RGB codes for filling the screen with different colors. And I'll show you that in a minute. So basically then you're gonna draw a white rectangle, and this is just updating the screen on where this text called space visualization needs to go.
Can you scroll a little bit?
I cannot. That's all the further. Okay.
Got it.
Okay. I'm like, I can't.
I can.
So if we hit run, if I hit run, what should happen is we should see a white rectangle in the middle of my screen with a black background and this word space visualization. Cross our fingers that it works today. So it just turned black and it didn't show up. So another thing I learned in CodeHS, you might have to run it a few times. So if we hit stop and run, see, then it pops up.
Oh.
So don't give up on the first try, second try. Keep trying until it keeps running. Unless you get that. And then you have a...
I'm not done. Line 18.
Yeah.
Okay.
Oh, it needs to be pushed over. That's why. Phil's distracting me because he's trying to run it on his screen. So basically, that's all that's happening. So Pygame, right? You're able to bring in different graphics into this screen in CodeHS. And you can, this is kind of cool too, so you can bring in different shapes. So for here, I thought about, oh, well, we can draw circles for the different planets. So if we bring this in, we are going to fill our screen with orange and draw a circle that represents the sun. So I hit stop and I hit run again, ta-da! So that brings up my next point. So if we want that to be back or black in the background, we can turn it back to the RGB like they had. Right, so now we have a black background with our yellow sun. You can, if you Google colors, Python colors, it'll tell you all the colors that you can possibly run in Python. Also any RGBs. See, so you can keep coloring this however you would like to. So that's kind of where it's fun for the kids. They can go in and, you know, customize it however they want to and play around with it and see what happens when they do different things. And then for the worksheet for this one, I actually have them draw 2 circles, one to represent the sun and one to represent the earth. And then you can take it one step further and have it show, have the kids start figuring out an angle to make the earth move around the sun for that one. It's, yeah, that's in there too. So it's a lot of fun. And same setup, right? We have our exit tickets, worksheets, answer keys. So then in lesson 5, so lesson 5 is where we bring in more advanced Pygame ideas. As I was just sitting here thinking about this, one other thing you could do is you could give them the code and make them figure out what happens and comment that out. Like if, which I always enjoyed doing because they would be like, I don't understand this. I'm like, well, you have 2 best friends, Google and your brains, and being able to play. So throughout lesson 5, I start to introduce interaction detection. So like this one is for collision detection. So if 2 things run into each other, like it will give you back, it will type in collision detected. You can do scoring, right? You're able to see as scores, as you start to interact with it, how you want your score to update. And that's all I did for lesson 5. Yes. Interaction and scoring. So now you have the ability to draw, you have the ability to interact with each other, and you have the ability to score after the first 5 lessons, which brings in lesson 6, which is
You gotta go out of this and go to the,
yeah, I was just trying to think if I want to show them this one.
oh, show them.
Yeah, I think I want to show them. So
Show them, show them, show them.
So, oh, yeah. So I did set up lesson 5 kind of different because I was worried I was getting too complicated. And so I wrote out example code for this to go through. And then I created the test that makes them go through and look at the code and answer these questions according to what they're seeing in the code. So that is lesson 5 because I was worried I was getting too complicated. So you can give them the code. What I suggested, you give them the code that starts their little game. And then give them the quiz and have them start to go through the code and figure out what is happening. Oh, yeah. So as you watch my screen, you can see the different, hang on, I know what I need to do. This one 480, and this one 400. See, this is where I forgot to change it to CodeHS size versus Pygame size. Okay, we'll see what happens. So you can see I have two different circles randomly moving around the screen. And then as they hit each other, right, the score goes up, which I don't know where my red ball went. Come back, red ball. Oh, see, that's what I mean by stopping and restarting, because now, hang on,
It looked like to me when the red ball goes to the right, it like goes off the screen.
it goes too far. Here we go. Yeah, because that said it 700. He said that. So basically the kids, oh, what did it again? Can go through and watch, see what happens, look at some of the comments on here, and then understand what is actually happening and how they can start to figure out to make things work for their actual game. I don't know why Mars keeps going away. There we go. So see, they hit each other, so this, it's giving feedback of, oh, collisions detected, my score goes up. There we go. So yeah. But you have to give them bounds, like how far they can go.
I love that you can, once they get in there, I mean, then you start going, okay, how do I make the red dot bigger?
Yeah,
How do I, and these are all the little things like, how do I make this, or what can I do here?
yep.
Yeah.
Which is what I guess I love about coding is that even if, so if they don't understand or they get super frustrated, you can decide as a teacher, okay, I'm going to give you this, but here's what I want from you based on what I gave you. Like, so if you do give them this and you say, okay, I want, you know, the blue ball to turn to a green ball and I want the, you know, it to turn to a bigger size. Go figure that out, come back and show me type
Right.
of thing. So
Right.
that's, yeah. Because they're still learning. They're still figuring out what's moving in or what's changing in the code.
And the worst case is they get errors and all this stuff, and then they got to go back in and just start over again
Yep.
from the beginning, and
Yep.
a little bit of trial and error.
Yeah. Which is what science is.
Right.
Okay, I'm gonna hit escape. There you go. And then as soon as I hit escape, right, everything kind of disappears. So then, lesson 6, I set it up.
Can you make it full screen?
Yeah.
Okay. Thank you.
Yeah. To where this is where you can decide on, you know, as a teacher, how you want this to be set up, how far you go into it. Basically breaking down your game into being able to set it up, creating the game object, moving it, detecting a collision, having a scoring, and then make sure it's looping until you hit escape type of thing. So now, and depending on time, right? Like, so you have all the foundations and all the fundamentals up until this for them to be able to create a game. It's all on how you want to present it to them because they have the ability to create the game objects, like I said. But what I did for this, for you guys, is here's the code to set up your game. If you want to give them that code, that's awesome. If you don't have to. And then here's different questions based on that code. So if they understand this code, then they can move on, type of thing. That's how kind of I would do it. Then, they're able to create these game objects based on what they learned in the first 5 lessons. Or you can give them this and make sure that they understand what these questions are before they move on. So that then you create the moving spaceship where, your key is pressed. That one you probably will have to give them because I did not build that into this lesson. That's up to you guys if you want to make them be like, okay, if you want it to move, if you want to control the movement, go Google it and figure it out. Collision detection, that was in lesson 5. Scoring in lesson 5. And then basically the answer key is everything that they are able to. So if we go back into the unit plan and we go all the way to the bottom, right, this rubric and final game code, here's your rubric that you can grade them on depending on how you feel comfortable grading. This is how I would do it to make sure they understand. But then I give you all the final game code, which I have to open up in here. So as I run this, right, I've initialized my game up here. I've set colors. That's another thing too. That brings up a great point. So since you know that you're going to be using these variables a lot, or these colors a lot, you can set them up as their own variables. So that way you don't have to keep writing out the RGB codes for them. It's however you want to do that. I'm drawing a spaceship here, creating stars and asteroids, doing my detection collision, right? Initializing my score of 0, have my while loop, on and on, displaying my score. So then finally at the end of all of this, you are able to come in here, run it, stop it, run it. There we go. And the kids can move. So this brings up another point. In CodeHS, it is kind of wonky here. Just make sure that if you see this show up down here, you can click in the screen. And then now you're able to move your spaceship.
And you have it set up to move with arrows.
Yep, arrows. So stars are good, right? Our score goes up. A star is collected, score of 10. Asteroids are bad. My score goes down a lot when I hit an asteroid. Collected a star. So basic gameplay in Pygame. I don't know. I feel like it was confusing.
No, I don't think so. Questions or comments from the teachers?
Oh, that's good.
So Amy said her 6th graders will love this. Yeah, you're welcome.
Yeah. And like I said, for like, there's so many resources out there to help, like, with the basics, and this went super fast and whatnot, but this book right here, yeah. So I know I had a lot of the standards for space are taught in 6th grade for science, for sure. So there's different ways that you can adapt this, as you know, you can create a depth, like an erosion game. You can create like going down a river and you hit a rock and you stop type of thing. Like think about stuff like that. There's just all these different ways that you can take this other than just space.
And I taught 8th grade, so I did a lot of chemistry and physics when I was doing it. And I can see some things I would definitely modify this and do. That's pretty easy. But I think I'm with Sue. She said, this is a great start and I will adapt it. The great thing, Jessica, you gave a lot of information and a good lesson plan, which is good,
Yes.
right? And so now I can take and figure out where I want to go with it and how much I want to use and what and then go from there. And I know you said, each one of these, I might even do it where I did, like different parts for, during this time and then refresh our memory later and then do it again and then refresh our memory
Yeah.
and do it again. So, or, I may just get to the point where I'm like, here, put this code in. Here's how it is. Can you manipulate it to do this?
Yeah.
And they're going to learn a lot by just doing that.
Yeah.
So I think there's many levels that you can take this. Okay. Any other questions or comments? Because then I'm gonna stop recording and then I've got some information to give you. But if there's any more questions or comments, please type them in now and give Jessica a chance to answer. Okay. I did my teacher wait time.
That's right. Embrace the silence.
Embrace the silence. Okay, I'm going to stop recording.